In this video, I will show you how to simplify fractions that have imaginary numbers, complex numbers, I. Now, the main thing to keep in mind is that we cannot have I in the denominator. So if you see I in the denominator, we have to get rid of that somehow. If the denominator is just a monomial, we can get away with just multiplying by I. We have to multiply in the numerator and the denominator. That way we are really just multiplying by 1, so we're not changing the value of the expression. So keep in mind that I squared is -1. So if I multiply by I, here's what I have now. So I'm going to have 9i plus 10i squared. Now, in the denominator here, I have -i squared. Now, in both of these cases, I squared is -1, here and here. So in this numerator, that means this is -10. And I'm going to go ahead and put that first, followed by the positive 9i that comes from right here. Right, so we remember that the imaginary part always goes second. Now in the denominator, I just have -1. So that's just +1. And having +1 in the denominator, we don't really need that. So I really am just going to erase that, and I'm just going to have my final answer. Okay, take a look at problem number 2. Again, when the denominator is a monomial, you really can just multiply the numerator and the denominator by I. So that's going to give me 9i over 9i squared. So that's going to be 9i over -9, because I squared is -1. So that's just going to be -1i, or simply -I. Okay, how about number 3? Again, when you just have a monomial, all you really need to do is multiply by I. So I'm going to multiply by I in the numerator and the denominator. Alright, in the numerator, I'm going to wind up doing a distributive property. So I will get 7i plus 9i squared over 8i squared. Now this is going to make -9. Because of course I squared is -1, so that's -9. So -9 plus 7i, we should put it in that order. And in the denominator here, I will have -8. Okay, again, because I squared is -1, I have -8. Alright, how about number 4? So again, I'm just going to multiply by I anytime I have a monomial in the denominator. I'm just going to multiply by I, doing the distributive property up here in the numerator. So that's going to give me -I plus 7i squared over -5i squared. Now, since I squared is -1, this is 7 times -1, so that's -7. And I will put the -I last. And then down here, I have -5 times -1, so that is +5. So this will be the final answer for number 4. Okay, now things get a little bit more interesting when you have a binomial in the denominator. when you have a binomial, what you want to do is multiply by something called the conjugate. So the conjugate of 10 minus 5i is going to be 10 plus 5i. Alright, the conjugate of the denominator. And I'm going to have to do the same thing in the numerator to keep the balance. 10 plus 5i. So if we do this multiplication, what we should have, this will leave no i's in the denominator. Let's check it out and see. So in the numerator and the denominator, we are doing a double distributive property. So 2 times 10 is 20, and 2 times 5i is 10i. Now negative 6i times 10 is negative 60i. Negative 6i times 5i is negative 30i squared. So meanwhile in the denominator, I'm going to have 100 and then 50i, and then now I'm distributing the negative 5i, so that'll be minus 50i, and then negative 5i times 5i is negative 25i squared. Okay, now remembering that I squared is negative 1, so that's going to make this become a positive 30 with no i's, and negative 25 times negative 1, this will also become a positive 25 with no i's. So now I can go ahead and combine my like terms. Okay, so what's going to happen? In the numerator, I've got 20 and 30, so that's going to be 50. And now I've got 10i minus 60i, so that's minus 50i. Now in the denominator, the 50i and the minus 50i cancel each other out. That leaves 100 plus 25. So that's 125. Now, when you think about reducing this, do you see anything that divides evenly into all three of these numbers? All three. Well, all three of these are divisible by 25. So that's what you want to do, is divide all three numbers by 25 and see what you get. Okay, so if you do that, then you get 2 minus 2i over 5. 125 divided by 25 is 5. So this is going to be the final answer for problem number 5. Let's take a look at number 6. Again, I see this binomial in the denominator. So to get rid of the I, I'm going to multiply by the conjugate. So notice when I do the conjugate, I don't change all the signs. I'm just changing the sign of the imaginary part. So I'm going to keep the negative 6, but I'll do negative 6 minus 8i. That's the conjugate of the denominator. And I will do the same thing here in the numerator. Negative 6 minus 8i. Alright, let's see what we get. Okay, in the numerator, I'm just doing a distributive property. So this is going to make negative 18i, and then negative 24i squared. So that's all I have here. Now in the denominator, I'm going to have to FOIL this, or double distribute, whatever you want to call it. So negative 6 times negative 6 is 36. Negative 6 times negative 8i is positive 48i. 8i times negative 6 is negative 48i. And 8i times negative 8i is negative 64i squared. Now watch out, because I see I squared, and I squared is negative 1. So if this is really a negative 1, then that's going to turn this into a positive 24 with no i's. Negative 64 times negative 1 is going to be positive 64 with no i's. Okay, so these are positives now. So combining like terms and such, so I'm just going to put the positive 24 in front like you do. So 24 minus 18i, that's our standard form. Down here, the positive 48i and the negative 48i, they're going to cancel each other out. Now I have 36 plus 64. That's 100. So 100. Now I need to divide all three of these numbers by something. I know they're all divisible by 2, so there might be something bigger that I can do, but I don't see it yet. So I'm going to start by just dividing everything by 2. If there's more I can do, I'll do that later. Okay, so far that's going to give me 12 minus 9i over 50. Okay. I don't think there's anything else that will divide into all three of these. So this is my final answer for number 6. 12 minus 9i over 50. Take a look at number 7. I see I have a binomial in the denominator, so I will multiply by the conjugate, which is negative 6 plus I. And I'll have to do the same thing in the numerator, negative 6 plus I. Let us see what we get. So here I'm just going to do the distributive property. 6i times negative 6 is going to be negative 36i. 6i times I is going to be 6i squared. Down here I need to FOIL or double distribute, whatever you want to call it. Negative 6 times negative 6 is positive 36. Negative 6 times I is negative 6i. Negative I times negative 6 is positive 6i. Negative I times positive I is negative I squared. Okay, so now keep in mind that I squared is negative 1. So that's going to turn this positive 6 into a negative 6. And that's going to turn this minus I squared. That's like minus negative 1. Minus negative 1 is the same thing as plus 1. So that's going to turn this into plus 1 with no i's on it. Okay, what now? So let's see, I have this negative 6. I'm going to go ahead and put that first. So I will have negative 6 minus 36i in the numerator. The negative 6i and the positive 6i cancel each other out. And now I have 36 plus 1, which is 37. That's a prime number, so that's definitely the end of number 7. For number 8, we will again multiply by the conjugate of the denominator. So that will be 1 plus 2i. And we will do the same thing in the numerator. Multiply by 1 plus 2i. We are going to have to FOIL or double distribute in both the numerator and the denominator. So 3 times 1 is 3. 3 times 2i is 6i. Negative 7 times 1, negative 7i times 1 is negative 7i. Negative 7i times 2i is negative 14i squared. Now 1 times 1 is 1. 1 times 2i is 2i. Negative 2i times 1 is negative 2i. Negative 2i times positive 2i is negative 4i squared. Now, I squared is negative 1. So that is going to turn this into a positive 14. And this negative 1 is going to turn this negative 4 into a positive 4. So what do I have here? So I have 3 plus 14, that's 17. I will put that in the front, standard form. 6i minus 7i is minus 1i, or simply minus I. The 2i and the negative 2i cancel each other out. That leaves 1 plus 4, which is 5. So this will be the final answer for number 8. So for number 9, I will multiply by the conjugate of the denominator. So that will be 10 plus 10i. And I will have to do the same thing in the numerator, multiply by 10 plus 10i. Okay, now time to FOIL, double distribute. 10 times 10, so that's 100. 10 times 10i, that's 100i. 5i times 10, that is 50i. And 5i times 10i is 50i squared. Okay, similarly, in the denominator, 10 times 10 is 100. 10 times 10i is 100i. Negative 10i times 10 is negative 100i. And negative 10i times 10i squared is negative 100i squared. These are going to cancel each other out. So, what now? I squared is negative 1. So, 50 times negative 1 is negative 50. So, this is a negative 50 now. Negative 100 times negative 1 is positive 100. So, let's see. So, I have 100 minus 50. So, that is 50. And then I have 100i plus 50i. So, that is 150i. In the denominator, I have 100 plus 100, so that is 200. Now, let's look and see, is there anything that will divide into all three numbers? The biggest number that will divide into all three is 50. So I'm going to divide all three of these numbers by 50. Okay, that's going to give me 1 plus 3i over 4. So this will be the final answer for number 9. In number 10, we will again multiply by the conjugate of the denominator. So that will be 5 minus 4i. And we will do the same in the numerator. So in the numerator, we are going to distribute. 8i times 5 is going to be 40i. 8i times negative 4 is negative 32i squared. In the denominator, 5 times 5 is 25. 5 times negative 4i is negative 20i. 4i times 5 is positive 20i. And 4i times negative 4i is negative 16i squared. Now, I squared is negative 1. So that's going to turn this negative 32 into a positive 32. This I squared is negative 1, which will turn this negative 16 into a positive 16. The negative 20i and the positive 20i will cancel each other out. So in the numerator, we have positive 32 plus 40i. In the denominator, I have 25 plus 16. So this will be the final answer for number 10. Number 11, we will multiply by the conjugate of the denominator. So that will be 3 minus 10i. And we will do the same in the numerator, 3 minus 10i. And let's see what we get. In the numerator, we distribute. 4 times 3 is 12. 4 times negative 10i is negative 40i. And in the denominator, we FOIL or double distribute. So 3 times 3 is 9. 3 times negative 10i is negative 30i. 10i times 3 is positive 30i. 10i times negative 10i is negative 100i squared. Now I squared is negative 1, so this I squared will turn this negative 100 into positive 100. Also, minus 30i and plus 30i will cancel each other out. So that is going to leave 12 minus 40i from the numerator over 109. For number 12, we will multiply by the conjugate of the denominator, which will be 8 plus 2i, and we will do the same in the numerator, 8 plus 2i. Distributing the 3i. Let's see, 3i times 8, that's going to be 24i. 3i times 2i will be 6i squared. Now the denominator, 8 times 8 is 64. 8 times 2i is 16i. Negative 2i times 8 is negative 16i. And negative 2i times positive 2i is negative 4i squared. Now remembering that I squared is negative 1, this I squared will turn positive 6 into negative 6, and this I squared will turn negative 4 into positive 4. Also, positive 16i and negative 16i will cancel each other out. So in the numerator, I now have negative 6 plus 24i. In the denominator, we have 64 plus 4, so that'll be 68. Now I'm noticing that all three of these are divisible by 2. So let's go ahead and do that and see what happens. Alright, so I'm going to divide all of these by 2. And I think this is going to be the final answer, because we're going to have negative 3 plus 12i over 34. Nothing else will divide into all three, so that makes this the final answer. Now number 13 is not a fraction, so all I have to do is FOIL this, or double distribute, whatever you want to call it. So 3 times 5 is 15. 3 times 3i is 9i. 5i times 5 is 25i. 5i times 3i is 15i squared. Now I squared is negative 1. So that's going to turn this positive 15 into a negative 15. Alright, so then I have 15 minus 15. So those cancel each other out. Okay, so these are gone now. So now I just have 25i plus 9i, which is going to be 34i. So that's the answer for number 13. So we're just going to double distribute here. So negative 4 times 4 is negative 16. Negative 4 times I is negative 4i. Negative I times 4 is negative 4i. Negative I times positive I is negative I squared. And sometimes it's helpful to think of this as negative 1i squared. Now, I squared is negative 1. So this I squared is going to turn this negative 1 into a positive 1. So now I'm back to just combining like terms. So I have negative 16 plus 1, so that is negative 15. And then negative 4i and negative 4i make negative 8i. So this will be the answer to number 14. For number 15, when you see something squared, you need to think that thing times itself. So this is 1 minus 2i times 1 minus 2i. Now 1 times 1 is 1. 1 times negative 2i is negative 2i. Then negative 2i times 1 is negative 2i. And negative 2i times negative 2i is positive 4i squared. Now we know that I squared is negative 1. So this I squared is going to turn positive 4 into a negative 4. Then we have positive 1 and negative 4, so that's negative 3. Meanwhile, negative 2i and negative 2i make negative 4i. So this is the final answer for number 15. Now, number 16, we will double distribute. So 4 times 7 is 28. 4 times 5i is 20i. 6i times 7 is 42i. And 6i times 5i is 30i squared. Now remembering that I squared is negative 1, this I squared is going to turn 30 into negative 30 because it's a negative 1. So now we have 28 minus 30. So that is negative 2. And then plus, and 20i plus 42i is 62i. So this will be the final answer for number 16. In this last portion of the video, we need to take the absolute value of these complex numbers. Now remember, the absolute value of a plus bi is the square root of a squared plus b squared. So for number 17, that's going to be the square root of negative 4 squared plus negative 7 squared. So that's going to be the square root of 16 plus 49. So that's going to be the square root of 65. And that's the final answer. This can't be simplified any further. Similarly, for number 18, we will have the square root of 6 squared plus 4 squared. So that's going to be the square root of 36 plus 16. So that's going to be the square root of 52. Now 52 is 4 times 13. So we've got radical 4 times radical 13, and the square root of 4 is 2. So this is 2 radical 13. So that'll be the final answer for number 18. So number 19, this is going to be the square root of negative 6 squared plus 8 squared. So that's the square root of 36 plus 64. But that's the square root of 100. And that's 10. So that'll be the final answer for number 19. And last but not least, number 20. This will be the square root of negative 9 squared plus 9 squared. So that's the square root of 81 plus 81. So that is going to be the square root of 162. Now that I think about it, I want to simplify this. So writing it as 162 is not the best way to go. This came from doing 81 plus 81. So, of course, that would be the same thing as 81 times 2. But since 81 is a perfect square, then the square root of 81 is 9. So this will be 9 and then radical 2. So this will be the final answer for number 20. That's going to do it for this video. I hope it was helpful, and I look forward to seeing you on the next video.